Okay, so some of the words we talked about on a few days ago. Chords, secants, and tangents. We're going to be talking about those three things today. This is called special segments, but it's basically you have chords, you have secants, you have tangents in the circle, and how do they interact? And it's kind of interesting. It's kind of crazy how this works. It doesn't matter where the chords are inside the circle, but if there are two chords within that circle and they intersect, you will, so it's important that X and Y are the same one highlighted. You are able to multiply them, and then they will be equal to any other chord. So A times B is going to be equal to X times Y, no matter where the chords are in the circle. So things that you need to be able to do is identify these, because when you, like on the test, it's not going to say, like, these are chords. It'll just be like a picture that looks like that, and you'll have to know to use that problem, or that formula, when the picture looks like that. And then you see this one, this is a secant because we've got two lines that slice through the circle, and they are secants that end. Like, theoretically they would extend forever and ever, but they don't. But they have two secants that intersect outside the circle. Just the way the picture is, they don't intersect, but or they don't go forever, but just imagine that they are. And so we're going to highlight this one. And that's going to be this side. We're going to highlight this one. It's going to be this side. And we are actually going to write something on this part to kind of tell you what is getting multiplied by what. But essentially it is the outside times the whole thing is equal to the outside times the whole. Outside times the whole, outside times the whole. So, that's that. I'm not going to dwell on this too long because it helps when you're actually doing problems. And then same idea here. So if you have a tangent that only touches the line, so it does not slice through, it just touches it at one point, it follows that same outside times the whole thing. And good. We've been over this a lot. Like, why do I make you guys do that? Because in the past I have not, and then people are watching YouTube videos or something. That's why. I believe that you weren't, but I can't see your computer. And it, like, even if you don't need to listen to the notes, it's fine, but having YouTube videos on your computer distracts others that need to listen to the notes. So that is the reason for that. Outside and whole. Okay, so it's the same idea, outside times the whole, outside times the whole. Okay, so the main thing to remember, make sure that you are multiplying the same line, because sometimes people want to get crazy and multiply 8 times 5 and then it's wrong. Don't do that. It's 8 times 4 would be the yellow side. For mine, it's yellow. You might have different colors. And 5 times x would be the other side. And that's all you have to do. This is actually pretty easy once you get the hang of it. I know that the formulas can be intimidating, but it's really not that crazy. So 5x equals 32. This is not going to end up as a whole number, but that's okay. You'll get like 6.4 when you divide those. For this one, I'm just going to do all of these, and we can do these fairly quickly. I just think it's helpful to have these highlighted so that you can see where things are coming from and why you're putting them in certain spots. Okay, so this is something that is, you need to see this because this is kind of interesting how this works. When these are perpendicular, notice it doesn't tell you what this side of the line is. it does tell you what the yellow one is. It's 5 and 3. So 5 plus 3 is 8. So like this whole line right here is 8. So we're actually going to do 8 times 2 here. Even though it says 5 and 3, it's 8 times 2 because you got to add those together. And then these two are where it gets interesting, because anytime you have a perpendicular, like two chords that are perpendicular to each other, and one is a diameter, that is like also one has to be a diameter, then these are going to be congruent to each other. All right, so if one is a diameter, has to be a diameter, and they're perpendicular, one is a diameter, and they are perpendicular, these are going to be congruent. So they have to be perpendicular and one has to be a diameter. I've said it like a bunch now. And that ends up being x squared, or x times x. It might be easier for me to show it as just x parentheses x for you guys to see it. But ultimately it becomes 16 and x squared, you take the square root, 4 equals x for that one. Alright, sometimes you will have to distribute. This is 3x on this side, this is 2 times x plus 4. So 3x equals 2x plus 8. Subtract 2x on both sides. And x is going to be 8. So set it up, you're just solving for x. Okay, I'm going to have you guys set up and solve this last one. You will have to take a square root at some point in this last one. So I'm going to pause, set this one up. Alright, so this one is x equals 2. Yeah. You don't want? This one? Yeah, let's look at it. So let's highlight. Oh, that's a 9. It looks like a Q. It's a 9.
Oh.
Yes, it does make it so much easier. You didn't. This one, it is the outside times the whole thing. This is the outside times the whole thing. But the outside and the whole thing are the same thing. So it's x times x. This is 3 times 12, but also you could say 3 times 3 plus 9. So you know where the 12 is coming from. Alright. 3 times 12 is 36. Okay, so I went kind of fast on the solving part because I'm left-handed and my hand was covering it up, but I'll give you guys a second to follow along with that. But the next one's not a decimal. Okay, so I'm going to pause for a second. I want you to at least set this problem up. Like, make sure you have the idea of setting it up correctly. Is this how we have it set up? 10 times 10?
Yes.
Okay. 100. And then 25 plus 5x.
That's what I did. I got there.
Okay.
Oh, it's because I have to
Subtract. Don't divide. I feel like people were dividing 100 divided by 25.
I think I had it.
Okay. Oh, you can't do that. 5x equals 75. 15, yeah. Yeah, I will say it has been a long time since we have just solved a generic solve for x problem, so it'd be good practice. $12 squared, not plus, no plus. Get out of here with the plus. Eight times 8 plus 6x minus 2. So don't let this overwhelm you. It's really, you're just going to add these things together. 8 plus negative 2 is 6. Yeah, so 8 times, not 8, 6 x plus 6. Then you distribute. Then you subtract 48. So that gets canceled out. It is too, but then yes, you are not done. Find CD. CD is 10. Yeah. CD is 6 times 2 minus 2, or 10. All right. That's all we're going to do.